Bismillahirrahmanirrahim. Assalamu alaikum. In our last video, we solved exercise number 1.2. Now we will solve exercise number 1.3. So, for the solution of exercise number 1.3, we first learn some definitions. The first definition is addition of matrices. Addition of matrices. What it means? It means when two or more matrices are added. Okay, what condition, what terms which follow for the addition of the matrices? Okay, let A and B are two matrices with real numbers as their entries. The matrices A and B are conformable for addition if they have the same order. What it means? It means we add two matrices if and only if they have the same order. What means order? In our previous video, in our previous lecture, we learned that what is the order of our matrices. So order means the number of rows and the number of columns. So if this according to this definition, two matrices will be added if they have same order. It means they have the same number of rows and the same number of columns. For example, if A is equals to 1, 2, 3 and 4 and B is equals to A, B, C and D, and A, B, C, D are any real number, then we can say that A and B are conformable for addition. Okay, the next definition is subtraction of matrices. What means subtraction of matrices? It means when we subtract any two matrices. Okay. Let A and B are any two matrices having real numbers as their entries. Then A and B will be conformable for the subtraction if they have the same order. In addition, we learned that two matrices will be added if and only if they have the same order. Likewise, subtraction is also be done of the matrices if both matrices have the same order. Okay. For example, A and B are two matrices. A is equals to 1, 2, 3 and 4, and B is equals to 2, 3, 4 and 5. Because order of A is equals to 2 by 2 and order of B is equals to 2 by 2. So A and B are conformable. Okay, simple, because they have the same order. They A and B are both are the square matrices having the same order, so A and B are the conformable for the addition or subtraction. Addition or subtraction. Okay, but here we discuss about subtraction, so we can say it is conformable for the subtraction. Now we learn how the addition and subtraction of matrices will be done. How we add or subtract two matrices. Okay, now it is how. First we learn that what is the subtraction and addition of two matrices, but now we learn that how it is performed. So let A is equals to 2, 3, 5 and 6 and B is equals to 3, 4, 6 and 4. You can take any matrices. Okay, now we add A and B. We get A plus B equals to 2, 3, 5 and 6 plus 3, 4, 6 and 4, which will be equals to 2 plus 3. How can I add 2 and 3? Actually, I am not adding these 2 and 3. No, I am adding corresponding entries. Okay, 2 plus 3, 3 plus 4, 5 plus 6, 6 plus 4, which will be equals to 5, 7, 11 and 10. Okay, so we will say that we add or subtract any two matrices their corresponding values. For example, this is A11, A12, A21, A22, which is equals to A, and B is equals to B11, B12, B21, B22. So A plus B will be equals to A11 plus B11, A21 plus B21, A12 plus B12 and A22 plus B22. Okay, it means corresponding values will be add with each other. Okay, we cannot add A11 with A12 and A12 with A11. This is the wrong. We add corresponding values with each other. Now let A is equals to A11, A12, A21, A22 and B is equals to B11, B12, B21, B22. So we get subtraction by subtract the corresponding values. So A minus B will be equals to A11, A12, A21, A22 minus B11, B12, B21, B22. It will be equals to A11 minus B11, A21 minus B21, A12 minus B12 and A22 minus B22. Okay, so in this way we can easily find the subtraction of two matrices. Now we will move to the question exercise number 1.3, question number 1. The question number 1 is which of the following matrices are conformable for addition. Okay, so A is equals to 2, 1, minus 1 and 3. B is equals to 3 and 1. C equals to 1, 0, 2, minus 1, 1 and minus 2. D will be equals to 2 plus 1 and 3. E is equals to minus 1 and 1, 0 and 2. And F is equals to 3, 1 plus 1, 3 plus 2, 2 minus 4, 2 plus 1. So F is equals to 3, 1 plus 1, 2, 3 plus 2, 5, 2 minus 4 and 2 plus 1 is 3. So which of the following matrices are conformable? First of all, we just find the order of A, B, C, D, E and F. So the order of A is 2 by 2. Okay, the order of B is 1 by 2. 2 by 1. The order of C is 3 by 2. Order of D, first we solve D. D is equals to 3 and 3. So order of D is equals to 2 by 1. Order of E is 2 by 2 and order of F is 3 by 2. So we can easily see that the order of A and the order of E is the same. So we can say that A and E are conformable for addition. Okay, the order of B is 2 by 1 and the order of D is also 2 by 1. So B and D are conformable for addition. Now the order of C and the order of F is the same. So we can say that C and F are conformable for addition. Okay, the question number 1 is solved. The question number 1 is very simple because here we only find the order, okay, order of each matrix, and then we compare each order with the other, and the matrices which have the same order, we can say that these are conformable for the addition. For move the question number 2, we first understand the definition. For question number 2, we know about additive inverse. Additive inverse of a matrix. Okay, so if A and B are two matrices of same order and A plus B is equals to O, which is equals to B plus A, then matrix B is called additive identity of matrix A. The definition is, if A and B are two matrices of same order and A plus B is equals to O and O is equals to B plus A, then matrix B is called additive identity of matrix. Here the question is that what is the O? Because we know that we take two matrices A plus B and B plus A. Okay, but what is O? O means a matrix which have all the identity, all the elements equal to 0. Okay, it means O is a null matrix. Okay, null matrix of the same order, which the order has A and B. The O has the same order like A and B. Okay, and 0 is called the additive identity of matrix of the A. Okay, additive inverse is the matrices. If we add two matrices and we get 0 matrix, then we can say that the other matrices is the additive inverse of the first matrix. Okay, now we solve question number 2. The question number 2 is that question number 2 is find the additive inverse of the following matrices. A is equals to 2, 4, minus 2 and 1. By the definition, we know that A plus B equals to O. Okay, and what is the O? O is a 0 matrix. Okay, so B is equals to minus A. Okay, if we put B is equals to minus A, okay, so by this definition we can say that the additive inverse of A is equals to minus A, and the minus A is equals to minus 2, 4, minus 2 and 1, which is equals to minus 2, 4, plus 2 and minus 1. It means that all the entries will be changing in the sign, will be changed with the sign. For example, 2 becomes minus 2, 4 becomes minus 4, minus 2 becomes plus 2 and 1 becomes minus 1 in the minus A. So the additive inverse of A is equals to the minus A. Okay, likewise we solve the next part. B is equals to 1, 0, 1, 2, minus 1, 3, 3, minus 2 and 1. It means the inverse of B will be equals to minus B. Okay, and minus B will be equals to minus 1, 0, 1, minus 2, 1, minus 3, minus 3, 2 and minus 1. Now the next part is C, and C is equals to 4 and minus 2. The inverse of C is minus C, which will be equals to minus 4 and 2. Okay, now we will move to the next part of question number 2. The D part is equals to 1, minus 3 and 2, 0, minus 2 and 1. So the inverse will be minus D the inverse minus t will be equals to minus 1, 0, 3, 2, minus 2 and minus 1. It means the positive sign will become negative and the negative sign will become positive in the additive inverse of that matrices. So E is equals to 1, 0, 0, 1, 1. So the inverse of E is minus E, which will be equals to minus 1, 0, 0, 1, minus 1. The next part is F, and F is equals to square root 3, 1, minus 1 and square root 2. So the inverse will be equals to minus of F, which is equals to minus square root 3 minus 1, 1 minus square root 2. The square root with square root, the minus will be become with the minus will come with the square root 3, not in under the square root, because if the it becomes a square minus 1, we will become if minus 1 become come in the under the square root, then it will totally change. Okay, the question number 2 is finished. We have done 2 questions of exercise number 1.3. The first was which of the following matrices are conformable for addition, and the second is additive inverse of following matrices. The question number 3 is if A is equals to minus 1, 2, 2 and 1, B equal to 1 minus 1, C is equals to 1 minus 1 and 2, and D is equals to 1, 2, 3, minus 1, 0 and 2. Then find. First we find A plus 1, 1, 1 and 1. What is A? Put the value of A. So what is the A? Minus 1, 2, 2 and 1, plus 1, 1, 1 and 1, which will be equals to minus 1 plus 1, 2 plus 1, 2 plus 1, 1 plus 1, that is equals to 0, 3, 3 and 2. This is the answer. Okay, the next is B plus minus 2 and 3. Put the value of B. We will get 1 minus 1 plus minus 2 and 3, which will be equals to minus 1 minus 2 minus 1 plus 3. This is equals to minus 1 and minus 2 is minus 3 and minus 1 plus 3 is 2. Now we will move to the next part. The next is C plus minus 2, 1 and 3. Put the value of C, we get 1 minus 1, 2 plus minus 2, 1 and 3, which will be equal to 1 minus 2 minus 1 plus 1, 2 plus 3, which is equals to 1 minus 2 is minus 1, minus 1 plus 1 is 0 and minus 2 plus 3, 5. So this is the answer. Okay. Now we will move to the next part, and the next part is D plus 0 1 0 2 0 1. Put the value of D, we get 1 2 3 minus 1 0 and 2 plus 0 1 0 2 0 1, which is equals to 1 plus 0, 2 plus 1, 3 plus 0, minus 1 plus 2, 0 plus 0, 2 plus 1, which will be equal to 1 plus 0 is 1, 2 plus 1 is 3, 3 plus 0 is 3, minus 1 plus 2 is 1, 0 plus 0 is 0 and 2 plus 1 is 3. So this is the answer. Next part is 2a. Okay, put the value of a, we get 2 into minus 1, 2, 2 and 1. It means 2 will be multiplied with all the entries. So 2 into minus 1, 2 into 2, 2 into 2 and 2 into 1, which will be equal to 2 minus 1 into minus 2, 2 2s are 4, 2 2s are 4 and 2 1s are 2. Okay, this is the answer. The next part is minus 1b. You can say this is the additive inverse of b. Okay, so put the value of b, get minus 1 into 1 and minus 1, which will be equals to minus 1 into 1 minus 1 into minus 1, which is equals to minus 1 plus 1. This is the answer. These questions are very simple. Now it minus 2 into c. Put the value of c. We will get 1 minus 1 and 2, which is equals to minus 2 into 1 minus 2 into minus 1 minus 2 into 2. This is equals to minus 2, 2 ones are 2 and minus minus is plus, and 2 twos are 4, so minus 4. This is the answer. The next is 3D. Put the value of D 1, 2, 3, minus 1, 0 and 2. We get 3 into 1, 3 into 2, 3 into 3, 3 into minus 1, 3 into 0, 3 into 2, which is equals to 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 minus 1s are minus 3, 3 zeros are 0 and 3 twos are 6. This is the answer. The next part is 3C. Put the value of C. We get 1 minus 1 and 2, which will be equals to 3 into 1, 3 into minus 1, 3 into 2, which is equals to 3 ones are 3, 3 minus 1s are minus 3 and 3 twos are 6. So this is the answer. We have done 3 questions of exercise number 1.3. Question number 4 is perform the indicated operation and simplify the following. The first part is 1, 0, 0 and 1 plus 0, 2, 3 and 0 plus 1, 1, 1 and 0. This is the bracket. This bracket shows that we first solve this portion. So 1, 0, 0 and 1 plus 0 and 2, 3 and 0. We will add first these two matrices, 1 plus 0, 0 plus 2, 0 plus 3 and 1 plus 0. This will be equals to 1, 2, 3 and 1. We take only these two matrices, okay? Now we will put this value on this place. So 1, 3, 2 and 1 plus 1, 1, 1 and 0. For your easiness, I will say this is A, okay, and after this I am saying put this in A, okay. This is the operation which we perform, okay. Now this will become 1 plus 1 2 plus 1, 3 plus 1, 1 plus 0, which will be equals to 2, 3, 4 and 1. This is the answer. Okay, in this question I'm taking this question as two parts. First, the bracket side plus the other matrix, but first I take this bracket and I am solving these two matrices, then I am add this this answer with the other matrix. Okay, and I get the answer. The second part is 1 0 0 and 1 plus 0 2 3 and 0 minus 1 1 1 and 0. Okay, first we solve this bracket. So 1 0 0 and 1 write as it is and solve the bracket. This will be equals to 0 minus 1, 3 minus 1, 2 minus 1 and 0 minus 0. 1 0 0 and 1 plus this bracket will becomes minus 1 1 2 and 0. Now we'll solve these two matrices. 1 minus 1, actually this is the 1 plus minus 1, 0 plus 1, 0 plus 2, 1 plus 0. This will be equals to 1 minus 1 is 0, 0 plus 1 is 1, 2 plus 0 is 2 and 1 plus 0 is 1. This is the required matrix. The first and second part are the same. Same means there is used the same technique. The third part is 2, 3 and 1 plus 1, 0 and 2 minus 2, 2 and 2. So we first solve this bracket, okay, and we will write this matrix as it is. 1 minus 2, we solve this, okay. So 0 minus 2, 2 minus minus 2, 2 minus 2. So 2, 3 and 1 plus 1 minus 2 is minus 1, 0 minus 2 is minus 2 and 2 minus 2 is 0. Now we will solve this. So 2 minus 1, actually this is the 2 plus minus 1, 3 minus 3 plus minus 2 and 1 plus 0, which will be equals to 2 minus 1 is 1, 3 minus 2 is 1 and 1 plus 1 is 1 plus 0 is 1. Don't forget use this equal sign, okay. This equal sign shows that we solve this question, so please don't forget to use this equal sign. Now the fourth part. Fourth part is 1 2 3 minus 1 minus 1 minus 1 0 1 2 plus 1 1 1, 2 2 2, 3 3 3. Here the operation is addition, so we add these two matrices, 1 plus 1, and the addition says that add the corresponding values. 2 plus 1, 3 plus 1, minus 1 plus 2, minus 1 plus 2, minus 1 plus 2, 0 plus 3, 1 plus 3, 2 plus 3. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. Minus 1 plus 2 is 1, minus 1 plus 2 is 1, and minus 1 plus 2 is 1. 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5. This is the required matrix. This is the answer. We have done fourth part of question number 4. Now we solve fifth part is 1 2 3 2 3 1 3 1 2 plus 1 0 minus 2 minus 2 minus 1 0 0 2 and minus 1. So here we also perform the addition. 1 plus 1, 2 plus 0, 3 plus minus 2, 2 plus minus 2, 3 plus minus 1, 1 plus 0, 3 plus 0, 1 plus 2, 2 plus minus 1. So this will be equals to 1 plus 1 is 2, 2 plus 0 is 2, 3 plus minus is minus, so 3 minus 2 is 1, 2 minus 2 is 0, 3 minus 1 is 2, 1 plus 0 is 1, 3 plus 0 is 3, 1 plus 2 is 3, 2 minus 1 is 1. This is the required answer. The last part of question number 4 is 1 2 0 and 1 plus 2 1 1 and 0 plus 1 1 1 and 1. Okay, we first solve these matrices because this bracket side. Okay, we first solve the bracket by the demos. So we solve 1 plus 2, 2 plus 1, 0 plus 1 and 1 plus 0 plus 1 1 1 and 1. If we don't use equal sign, then there is a big mistake, so always use equal sign. 1 plus 2 is 3, 2 plus 1 is 3, 0 plus 1 is 1, and 1 plus 0 is also 1. Now write the second matrix. 3 plus 1, 3 plus 1, 1 plus 1, 1 plus 1, which will be equals to 3 plus 1 is 4, 3 plus 1 is 4, 1 plus 1 is 2, and 1 plus 1 is 2. This is the required matrix. So we have done 4 questions of exercise number 1.3. Before move towards question number 5, we just learned some properties of addition of matrices. commutative and associative property of addition of matrices. Let A and B are any two matrices and are conformable for addition, then according to commutative property of addition, A plus B will be equals to B plus A. What is the commutative property of matrices? We take any two matrices which are conformable for addition. Conformable for addition means the both matrices having the same order, so we can easily add them. Then according to the commutative property said that A plus B will be equals to the B plus A, because the addition property of the commutative property of addition holds in the matrices always. Okay, the next property is associative property, that if A, B and C are three matrices having same order, then A plus B plus C will be equals to A plus B plus C. Is called associative property under addition, and associative property always hold under addition in the matrices. We already learned about the additive identity of a matrix. Okay, sorry, additive inverse of a matrix. So the additive identity of a matrix. What is the additive identity of the matrix? If A and B are two matrices of same order and A plus B equals to A, which is equals to B plus A, then matrix B is called additive identity of matrix A. The additive identity is, if we take two matrices which have the same order, then if A plus B is equals to A or B plus A is equals to A, then B is called the additive identity of matrix A. Okay, it means that if we add any matrix in a matrix A, there is no difference before and after adding that matrix. Okay, so it is only the additive identity. Matlab identity, it means it is only the identity matrix of A which will be added in A, and the answer is the same. Okay, we will solve question number 5 to onward in our next video. Allah Hafiz.